Okay, everybody, for your homework, you'll be making two concept maps. But I want to tell you what a concept map is, and then in the second video, kind of why this isn't just a goofy exercise, like why making the concept map is actually important. So let me give you an example of a concept map using something that you already know about, linear functions. So if I ask you kind of like, what do you think about when you think about a linear function? Probably you think y equals mx plus b. That's my guess. Or maybe you also think, oh, it's a line. It's a graph that has a line. What a concept map is it's an organized summary of all of the information that you know about a subject, where all of the connections are clear between the different ideas. So for linear functions, there's a lot of different things you know. So you know that there's like different forms the equation can take. You've got the y equals mx plus b, but then you've also got the form where you've got 2 points. You've got the slope times x minus an x coordinate and then plus a y coordinate. And you use those different forms in different situations, and so you can annotate that. And then as far as the function itself goes, it looks differently in different representations. So you can see it as a table and as a graph and as an equation. And you can see the same features in all three representations. So you can see the growth here in the table, and the growth is there in the equation. And then you can also see that same growth in the growth triangles in the graph. Same thing for the y-intercept, all three representations. You know things about how to solve linear functions. And for linear functions, it's simple enough that it's like always the same approach to solving them. And so here, instead of giving an example of how to solve one, if you solve for x using m and b, that's kind of a general solution for all possible linear equations. You know that a linear equation is just one example in a whole series. So what's more complicated than an equation with an x in it? It's an x squared and then an x cubed. So linear is an example of a first degree, but that forms a progression. And so that's like an important fact to realize about linear functions, is that they're a simple example of a more general type of equation, a polynomial. So you just learned about inverses. So when you originally learned about linear functions, you probably didn't think about their inverses. But now you can see that all linear functions have inverses as long as the slope isn't 0. So as long as they're not actually constant functions. And then you can solve for what the inverse would look like, and I've done that there. So you see there's actually a whole lot of different stuff to know about linear functions, and it's all kind of connected together. So that's your job when you're making a concept map. It's to get everything you know on the page in an organized fashion that shows the connections. So for your first concept map, I'd like you to make one about parametrically defined equations. You know a lot now about how to think about the path, the shape of the path that a parametric defines, and also about the motion along the path. And those are two separate aspects of what a parametric set of equations tells you. So as a first draft, try and make a really complete concept map of parametric equations. And then for your second concept map, which is also due on Thursday, you should choose any other concept from this unit. Here's what I think are some of the major new things that we've thought about this unit: inverses, logarithms, composition of functions, and piecewise defined functions. Inverses we've learned quite a lot about. Piecewise defined functions are relatively simple. So if you choose something like piecewise defined functions, you're not going to have as large a concept map. So I'm going to expect that you would tie in some of these other ideas. For example, how do you think about the inverse of a piecewise defined function? Or how do you think about the composition of a piecewise defined function? So please do those things if you choose piecewise. Okay, thank you. And we'll maybe have some time to get some feedback on these on Thursday. Thanks.